John Pretty talking about Fire and Fury.
Thank you very much. Good morning, Philadelphia. How are you? I'll give you a second to get back to your seats. Today I'm going to talk about a project I've been working on for a little while. But first of all, how many people came to Boston last year? A few of you. So cast your minds back. Maybe you saw me chatting to Rob at some point during those couple of days. And we worked on my previous main project, Magnolia. And I was trying to do some generic derivation on Doobie, make it faster than it was with Shapeless. And I opened a PR on Doobie, and Rob had a look and found an issue with Magnolia, closed it. And I thought, well, I've got an 8-hour flight back to Europe. I'll just spend that flight trying to fix Rob's problem. So I replied, explaining what had happened. Because I got on that plane with great intentions of fixing a bug in Magnolia. And as soon as I got into the air, I tried to run SBT. Something didn't work. There was a stack trace thrown. I had no internet connection. I had 8 hours ahead of me, sat in the same seat, with no prospect of getting this work done. So I thought, I'll write a build tool. And here we are. I'm not quite ready to ping Rob yet, but Fury is the result of an angry flight I took back to Europe a year ago. And it was the culmination of several years, actually, of thought about this problem. But that was the straw which sort of pushed me over the edge to actually go and try and write something. Fury is a build tool, in the same way that SBT or Maven is a build tool. But I also like to think of it as a dependency manager. And I actually think the dependency management is maybe a little bit more interesting than the building. Let me tell you a bit about what that means. So first of all, Fury doesn't really fit in with existing conventions. I don't try to see what other people have done and do it better. I'm looking to take interesting ideas and throw them into this tool and experiment a bit and see if we can make something that's actually significantly better rather than just fixing the most immediate problems we have. One example of that is that I define builds not as code that we have to run and compile, but as data. A build is a value. Fury primarily uses source dependencies rather than binaries. Binaries often produce conflicts. Sources can, but they have some advantages, which I'll talk about. And there's no build file to edit. In the same way that when you use Git, you're not editing a file which somehow describes your repository. You run commands, some mutation happens behind the scenes, and you have a different state afterwards. That's the same approach that Fury takes. And builds are just hashes. This is a new feature I've added in the last couple of weeks. We can talk about a hash, and that will uniquely resolve to an exact build. I'll tell you how that works later as well. So why am I doing this? What problems do I need to fix? How many people here are entirely 100% happy with their build tooling? OK. Can you talk to me afterwards? The guy put his hand up. Thank you. We'll have a chat. Possibly my biggest problem with builds is that I just don't understand them by glancing at them. Now, you can read an SBT build file, and I'm not going to spend this whole talk criticizing SBT. There are some good things and some bad things about it, but one bad thing is that I can't just read that build.sbt file and immediately know what it does. I can look at the code, I can visually pattern match on certain things I expect to see and maybe get an idea for what build graph it's representing. But in order to know with certainty, I have to actually read the code and study it in a lot of detail. So the builds we're not familiar with working with clear builds. Maintaining them is difficult. In large organizations, you often have one person, or maybe more than one person, who is dedicated to maintaining the build. That seems like a lot of work for something that, in my opinion, shouldn't be so complicated. And one consequence of this is that the Scala ecosystem moves slowly. Part of that is that releasing and sharing libraries is difficult. We use usually Sonatype or Bintray. There are challenges with getting your library on there. It took me over a year, I think, to publish my first library to Sonatype, and I've written a whole build tool in less time than that. So I'm already ahead of the game. And of course, everybody is familiar with compiling Scala being a general pain point that is slower than we would like. I can improve that a little bit, but there won't be such dramatic gains here as there will with sort of more radical solutions. So the choice to use data to represent builds was one of the ideas I settled on very early on. A dependency graph in Fury is not Turing complete. It's not code. You don't need to run it. You don't need to compile it. It is just data. It's a data structure. We have an algebraic data type which represents a build. That gives us a lot of advantages. They're simple. They're fast to analyze. We can develop tooling around them, which can study the build, analyze it. It's much more tangible to work with than it would be to try and analyze code and find out what it's doing. The choice to use source dependencies was one I made based on a desire to not have runtime linking errors. Now, when you depend on binaries and when Maven or SBT silently upgrades one minor version or maybe even a major version of one dependency, one transitive dependency to the same as another one, and you just kind of hope that's going to work. Sometimes it doesn't. Sometimes you get a class def not found or a method not found exception. These are problems that you discover at runtime, which is the absolute worst time to discover a problem. You want to discover things at compile time if you can. And having the compiler check everything from source is, I think, the best way to guarantee modulo compiler bugs, but to guarantee that things will work when you actually come to run them. Most of what I do in my career has been trying to move errors from runtime to compile time, and this is no exception. We don't have to wait for binaries to be published in order to depend on sources. We can depend on any commit hash we want. So we're up to the minute with having a build that works. And anybody can write a build for any project. The build doesn't necessarily need to be inside the same repository for the code it's building. It can be external. Now, what that means from my point of view as someone who's trying to bootstrap an ecosystem around Fury, I'm ambitious, but what that means is that I don't actually have to persuade every single author of every library to switch to Fury. I don't want to do that. That would be arrogant. What I would like to do is persuade a few people who are signed up to these ideas to maybe help me and others convert some part of the ecosystem. And they can do that. They can publish builds for any project they like, and anyone can then use those builds. And that point I already made. So the command line interface, this is the Git-like interface we have to interacting with your build. This is, I think, one of the nicest aspects of actually using Fury. You run commands. They either pull information out of the build and display it for you, give you information analysis, or they allow you to mutate the build. This point here that it has colorful output might seem a little bit trivial, but as much as possible, at every opportunity, I've tried to make interaction with Fury intuitive. So, for example, if you see a project name listed, it will always be in the same color. If you see a module name, it will always be in a different color that's always for modules. You get the visual hints as much as possible and as often as possible to help you learn what you're seeing and understand the build and how it works. We get tab completion, which is more or less a necessity, I think, for having a nice-to-use command line interface. And it's pretty smart if you're selecting a module that's inside a project, and you specify the project first, it will only offer as completions the modules that are in that project. So it can be pretty smart about how that works. And here are a few of the commands. This is just a selection, not in any order. Just have a glance at that. Those are some of the typical interactions you might make with Fury, and you can read those and you can speculate about exactly what they're doing and how Fury's model works. I'm not explaining it at this point, just giving you a taster for the sort of commands you might run. And finally, builds are now represented by hashes. Every build is a value. It is a data structure. We can just take a hash of that, and then that acts as an index to that build. If the build changes in any way, any little detail changes, the hash changes. It becomes a different build. What this means is if we refer to one hash representing a build, if we're making a reference to it from one build to another build, then that hash is immutable. It won't refer to a different build on a different day. And my goal, ultimately, with all of this, is not to just produce another build tool that fixes the problems that we have with our current technology, or sort of identifies that something is slow and makes it faster. What I want to do is to give Scalars the best build tool experience, not just in the Scala ecosystem, but in the entire programming ecosystem. That's my ambition. I might achieve it, I might not, but I'm going to have a go anyway. So building, I said, is the less interesting of the two tasks that Fury does. I'm just going to show you a quick demo. We're typing a command at the top here. Hopefully, well, you don't need to see it too clearly, but we're now running Fury, which is going to start a build. It shows you immediately a graph of the dependencies between these modules. This Kaleidoscope is a project. This is a module within that. We get progress updates thanks to BSP. This is developed at the Scala Center. We've just had some errors occur here. This video was taken when there was an off by one error in the error reporting. So there is actually only one error, but it says two. It's been fixed now. And the error is that I've used a type that doesn't exist there. But you'll see we get this nice output here. It points to the file. We get the line number. We highlight the entire token that is wrong. And a few things to note. You probably noticed things were being run in parallel. That's thanks to Bloop. Bloop is keeps hot Scala compilers running on your system and will dispatch work to them. What that means for me as a developer of Fury is I can just hand work over to Bloop, and Bloop does it fast, and it does it as fast as possible. That was developed at the Scala Center. And you noticed that it was giving us good indications as to what was building at any time. The feedback gets updates whenever the compiler changes from one phase to another phase. So that's why we're able to see these updates. So all look good? Yeah? So I'll talk about a few of the concepts in Fury. Layers are maybe the most fundamental part of the distribution side of Fury. A layer is a collection of projects, and a project is probably very much consistent with your existing expectations for what a project is. It has a name, probably a license. It probably resides in a single Git repository, but may involve several compilations. You might compile some macros and then compile some code which depends on those macros. That's two invocations of the compiler, which we call modules, but together that is one project. And an observation I made very early on is that modules, which are invoking the compiler with some source files, with a class path, with some compiler parameters, and producing at the other end some class files, or errors, but hopefully class files, we can join these together into a graph, a compilation graph. And that's essentially all that Fury is doing. It's orchestrating that DAG of modules, of compilations. It's compiling things in the right order and passing sources and class files between the nodes in the DAG as appropriate. Layers, which contain some collection of projects, maybe just one project, maybe many. They may be published on IPFS. How many people know what IPFS is? Not many. I have a slide on it later. For now, just imagine it's cool. Because it is. We have an example here. These are probably familiar projects to some people in the audience. These white rectangles are meant to represent layers. Inside the layers are projects. This is all a bit hypothetical. I didn't actually check how many projects or modules are in each of these, but the blue dots are modules, the green squares are projects, and these are layers. So imagine Circe, Spire, Doobie have published layers. Now, if Doobie and Circe depend on the Shapeless project, they rely on Shapeless APIs, and that code needs to be on the class path, then we first of all need to have available in both of these layers the Shapeless project so we can actually depend on it. So these arrows are indicating importing from one layer to another. And having done those imports, we're now able to create dependencies between the modules. These orange arrows represent dependencies. So does that all look okay? Pretty typical. It's all imaginary, but imaginary in the sense that I've just made up what the modules and links are. But we could go further. If we're importing from Shapeless, all of these projects are in the type level ecosystem. So maybe type level would like to aggregate these layers together into a single layer that they call type level. It doesn't define any project itself, it's empty, but it imports all of these. So if you were to import type level, you would have access to all of the type level projects to depend upon. But maybe the community build would want to grab all of those type level projects and make them available too, along with things like Scala test. And then in our project, our modest project down here, we could just pull in the dependencies, or sorry, pull in the community build layer, and we would have access to everything that includes. So that would be a typical usage. If we wanted to depend on one other thing that wasn't in the community build, we just add another import to another layer. We'll see more about that in a moment. So schemas are a solution for cross-building. How many people here maintain libraries that require publishing to more than one target? How many people maintain libraries that don't require publishing to more than one target? So the vast majority of people who are publishing libraries publish cross-builds. So this occurs quite frequently. We often need to support different versions of Scala, 2.11, 2.12, 13, maybe Scala 3 again in a year or so. Sometimes we depend on compiler internals, which means we need to depend on the minor version, or publish for each minor version as well as each major version. We may publish for, or need to build for Scala.js or Scala native as well. We could even have dependencies on a library that has two commonly used versions. So if you depend on Shapeless or CATS or Scala Z, which are widely used and may need to coexist on the same class path with your project, you maybe want to choose one version over another, and that might mean that anybody publishing a library which depends on that publishes multiple versions. This is a multiplicative problem. We may want to support entirely different libraries. You could write a library that offers bindings to CATS or alternatively to Scala Z. So Fury's solution to this is to use something called Schemas, which is essentially a complete copy of the entire layer. You can think of it like that anyway. So any detail you specify in a layer will be copied once for each schema and can be tweaked as necessary. You can make small variations to these schemas that apply only to one of them. There's no sort of matrix of Scala.js against, or sparse matrix of Scala.js, Scala native against Scala 2.11, 2.13, and so on. They're all peers, effectively. But each one is a variation, a tweak on the main build. I could have designed this without schemas, without the entire concept. I don't like adding new concepts if they're not really necessary. We could have had separate layers for each one. You just publish the same layer multiple times. But it would be actually a lot of work to maintain multiple different layers at the same time, I think. And most of the changes you make will actually apply globally to all schemas. So if you add a new module to your project, you need some more macros. That is a change that you probably want to affect every single schema. Whereas if you're adding a source directory containing shims, that will only apply to one schema, probably. Maybe you've got Scala 213 shims that you want to import. That's a separate, that needs one little tweak to just one schema. Because it is an entire copy of the layer, you can change any aspect of it. You can add new projects that only exist in one schema. I wouldn't recommend you diverging too far from between the different schemas, but you can make any change you like. And then it becomes a maintenance problem, and to a large extent an understanding problem. If you have these variations in the schemas, how do you as the developer understand how to interpret those differences? Well, one thing you can do is you can compare any two schemas, and Fury will tell you what is different between them. That gives you instant feedback. It'll tell you straight away that maybe you're using a different source directory for one module than you are for the same module in another schema. So let's go back to this. This is the same layout we saw before. This was only part of the story. When we import, we actually import a particular schema from a layer. So maybe we're importing the schema that's called Scala 212. Schemas can be called anything, so maybe type level decide to call their schema just latest. But we have to specify which schema it is. So we have this sort of structure here. And we might have some situation here where the definition for Circe and the definition for Doobie both import the Scala 212 schema of the shapeless layer, but different versions of it. There's been some slight change to this layer between when Circe imported it and when Doobie imported it. Now, what Fury will do is if the definition of this project happens to be identical in both those layers, which may occur, that's not a problem. If the definition is identical, that's considered the same shapeless project here, this green square. But if there is a difference, that is a conflict. That is commonly known as diamond dependencies. We have this, which is a diamond. I've actually drawn the arrows this way because it makes it look more like a giant mushroom cloud, which is much more appropriate. The problem is we have a module down here, and we want to depend on shapeless core, and we have two possible routes. It's ambiguous as to how we would resolve this. Fury won't let you continue at this point. You have to fix this somehow. This isn't going to automatically upgrade one to the other. It will pass the question down to you to come up with a solution. And you have a few options. You can go and modify Circe, change it to point to this tag here. You could change Doobie to point to this layer here. You could redefine, or you could copy the shapeless build, or one of the shapeless builds, down to your project. So you redefine shapeless, which will then shadow this version, and it will unify the version that's available here. There are a few techniques, and I think we will, if people start adopting Fury, we will learn what works well and the best ways of making these changes. But essentially, it's down to you to resolve the dependencies. So just to recap the model, layers are Fury's units of distribution. They contain projects, which are the units of resolution. What I mean by that is that we have to come up with a unique mapping, a one-to-one mapping between a project name and the project definition. And modules are the units of compilation. Modules have various different types. Most of them will be libraries. You're just compiling some source code, producing class files from that. But Fury also supports applications. These are very much like libraries, except in addition, they will be run. So they will run a main method, and that main method can do whatever you want it to do. It can generate source files, it can run tests. The source files that you generate could potentially be passed into a later module for compilation. So you can do code gen, you can connect to a database, you can do almost anything you like. We also support plugins. These are compiler plugins. So if you want to define a plugin that runs during compile time, that's just a different kind of module. And you can even define compilers. So everything, including the Scala compiler, must be defined in Fury when you, if you want to use it. The model has dependencies, binaries. We can depend on binaries. There's no special magic with how they resolve. And you get the same problems you would get with Maven or SBT with updates. Corsair deals with them. We manage repositories. So in your layer, you will have references to remote repositories, Git repositories, and from those, that'll be tied to a particular commit hash, not to a branch or a tag. And sources you can specify within those repositories to associate with the module to compile. And we have a few other things like parameters, environment variables, which are relevant to various different aspects of running the build. So let's talk about distribution. There are about three kinds of things you might want to distribute, to share. The builds themselves, the specifications, the compilation, so given a module, sharing the binaries that are produced from that, and then actually publishing to the world the binaries. So I mentioned before, Fury stores every build specification on IPFS. This is the Interplanetary File System, which is a rather grandiose name for a very ambitious project, which intends to provide a universal content hash-addressed, I think it's Merkle, DAG, all the buzzwords, blockchain, distributed network or content network. So what it means is that you can ask IPFS to give you data from a hash. You give it a hash, it will give you the content. If you give it content, it'll give you a hash. It's a bijection between hashes and content, which works universally. When you run IPFS, it will automatically connect to nodes near you, and it will route your requests for the content to a node that has that content, and it will give you the content. And you can provide content, it will give you a hash, and then it will make that content available indexed by the hash to other people. Builds are permanent, that hash always relates to the same content. And yeah, this is just copied more or less from the IPFS website. If you hadn't heard of IPFS before and you don't care about build tooling for Scala, then at least take away from this talk that IPFS is a cool and interesting technology and investigate that. So maintaining builds is almost more important. Maybe it's almost certainly more important than creating them in the first place. The maintainability of the build is a more important thing to optimize than just the initial creation. But if we have these builds defined in this way, we have layers referring to layers that are available as data, as maybe quite a large data structure that contains the specification for every project we depend on, with references to Git hashes and Git repositories. We have, at our fingertips, access to the entire tree of our build, back to the very base projects. Now this is hugely powerful. We can do a lot with this. I've recently added some changes to make it very easy to work with other layers. So imagine we are working in our workspace. This doesn't really have a name, but it's the current project. It doesn't have a name until you publish it. And our current layer maybe has this hash and depends on type level. So we're importing the type level layer into our layer. Type level imports the Circe layer, so these two are the same, and Circe imports shapeless. We're currently, when we create the project, when we start doing our work on that layer, we're sort of pointing Our focus is on our own layer. But we can change the focus. We can say, select this layer, and we can reference it by name. This is the name we imported under. So we actually follow the path. We go to type level, Circe, shapeless. We're now pointing, our focus is now on the shapeless layer. Now, the behavior of Fury, when you're running it inside a directory that has this changed focus, is that it's as if we're modifying the shapeless layer directly. We have access to the build, so why not make it really easy to make changes? And we can make changes. So this hash here, after we've made a change, like we've removed a dependency from the shapeless module, we're saying it no longer depends on macro paradise. If we made that change, the module specification would change, the project specification would change, therefore the layer specification would change, its hash would change. So this is now pointing at a different hash. Consequently, Circe needs to be updated to point to this new version, and then Circe's hash will change. Same for type level. This all happens automatically. You just run that command there, and when you're focused on this shapeless layer, and your workspace is now pointing at the updated version. We could even, because we have access to the sources of shapeless in the shapeless project defined in this layer, we could say fork shapeless out of managed space into a local directory on our hard disk. And we could start making changes to shapeless directly, which are reflected as soon as we try and run the build from our workspace. So this makes it extremely easy. It removes all the barriers to getting started contributing to open source. You can access anything you depend on by source. You can have it as a project on your hard disk. You can make changes, and you're able to modify your entire build. And then it's up to you to contribute back with the changes you make if they're valuable. And that appears twice. Oops. There we are. I forgot to refresh. I made that change. That was the last change I made. So we would having made that change to shapeless, we would then switch back to our workspace by selecting the base layer, which is just referenced by a dot. So having done that, we might like to share that with somebody else. So we can run this command, Fury layer share, which will give us this Fury schemed URL. We can give that to someone we're working with sitting next to us or on the other side of the world, and via IPFS, they will immediately get a copy. When I say immediately, I'm talking under a second. They'll get a copy of that exact build, and they can run the same thing on their computer. They can then make changes and pass you a hash back over chat, and you can make those changes yourself. If you wanted to start with an existing layer as a template or just to work on it, you can clone it. That works very much the same as git clone. We specify the hash there. And if you want to import, you can import by hash. When you import, you need to give it a name. So we're going to import whatever this was. And remember, importing makes available any project defined in that layer, either directly or transitively through the layers that layer imports, and we can then depend on them. Who likes working with hashes? a few people. It'd be much nicer to be able to say something like this. So I'm in the process of specifying a way to get nice names for the layers. This is sort of tagging, if you like. And that's how it would work if I were to provide a default service. And I do intend to do that will resolve a name like that to a particular version of a particular layer. But I don't want to have any centralized bottleneck or single point of failure. So if type level wanted to run their own service, I'm specifying as well how they would do that, and it uses DNS and IPFS. It should be easier to set up your own service than to publish to Sonatype for the first time. That's my baseline. We can also have mutable references. If you import this latest version could be a different thing from one day to the next. That's desirable. if you want a simple import that doesn't need you to actually go and check what is the latest version and so on. But you might be worried that, well, if we're pointing to this, then our build isn't necessarily repeatable from one day to the next. Well, this will actually resolve the hash, and the reference will always be to the hash of the build on the day that you import it. So releasing, as I said just now, is notoriously difficult. I've had huge trouble doing this. So this is something I would like to make easier. There is an open PR that was opened a couple of days ago, developed by Virtus Lab to provide facilities for publishing to Maven Central directly. And what that will involve is for Fury to specify some details that are necessary to actually get the artifact, the POM details. You don't have to edit a POM file. I'll just ask you to specify on the command line what those details are. You can specify, given that we're working with a graph of dependencies between modules, you'll be able to specify basically how fat your jar is. Do you have releases for every single node in your compilation graph, or do you just release one thing which includes all of the dependencies? And it'll work out what subgraphs of modules need to be published and what dependencies it would depend upon. And it'll be as simple as running a command like this. The thing that probably varies from each release is the version, so that will be specified on the command line. But this will fire up a load of HTTP requests to Sonatype or Maven Central based on some publishing details you provide to Fury. Support for IDEs is important for many people. I've been using Vim for the last lifetime, and I believe other people prefer to use IDEs. And thanks to JetBrains, particularly Justin Kierza on the Scala IDE, IntelliJ, he has developed a BSP, this is the Build Server Protocol, server within Fury. So when you run Fury, it allows an IDE, such as IntelliJ or Metals, which is Scala plugin for VS Code, to connect to Fury and ask it to do things like compile. It'll be able to import details from the project structure and module structure within Fury. This is something we implement once with BSP, and because both Metals and IntelliJ support BSP, they can get all the information they need seamlessly. If another IDE or even a Vim plugin wants to do that as well, then it'll have all of the features straight away. So a lot of gratitude to JetBrains for supporting that. For plugins, I think this is something that people like about SBT. Would you agree? Yeah, people like the fact you can just depend on a plugin and you get new functionality. And the set of features you get from plugins is actually quite diverse. And so the question's often raised, how will Fury support plugins? And I've thought long and hard about the best way to do this and concluded that it won't. I really don't want to have a plugin architecture that sort of has to shoehorn some feature requirements through an API that I'm definitely not going to get right the first time, and then create all sorts of implicit dependencies from me on other people's code that I have to maintain simply because the ecosystem depends on those plugins. That's an unfortunate situation if I were to end up in it. So my answer is to simply not support plugins in the form that we're maybe familiar with. That doesn't mean that the features that you currently get through plugins will be unavailable. Because it will be possible to support a lot of things natively, for example, and then the plugin API is actually just pull request to Fury. And if it is providing, if the functionality in the plugin is providing something that's useful to a large audience, then that's something I would very much like to include. Fury's library interface, we can define a lot of things that are currently plugins simply as libraries or libraries to application modules. A lot of things will currently work in the existing model that you see. So I found a list of plugins somewhere online, and of these, there's different solutions for each one. So something like Warp Remover, it's just a compiler plugin. That's a matter of adding a dependency to Warp Remover. Native Packager, that's something I don't think needs to be part of Fury at all. It happens entirely after Fury runs. Fury will convert source code into a jar file. After that, I don't care what you do with the jar file. So write a make file that will take that jar file and then package it in some way. And you've got the full flexibility of make and your shell to work out what to do there. Something like Scala format, which operates on source files, that doesn't need to be part of Fury itself. So that can happen before Fury. And then these others, things like Corsair, Corsair is built in. JMH, support for benchmarking, that is built in. You can just write a benchmark module and run benchmarks. Scala.js, Scala native, we can output to them. SPT Sonotype, this is all part of the release functionality. So a lot of you know me as Propensive, which is my Twitter handle. Maybe fewer of you know that Propensive is actually just the name of my company. And I think it's very easy to confuse the two, maybe partly because I'm the only person who works with the company. And I'll just tell you a little bit about what Propensive does. I organize training around the world, mainly Europe, actually. And I organise a conference, Scala World, which taking place this September in the Lake District in England. And the rest of my time, I mean, these two add up to a full-time job, and then the rest of my time, I'm writing open source software. But basically, the training sort of allows me to survive with food and water and shelter. Scala World sort of breaks even, and then developing open source software is just like a massive drain on all my resources. But I actually enjoy it a huge amount, which is why I keep doing it. That is what Propensive does. And then I'm sort of asking you to take a leap of faith to adopt Fury, given that it's backed up by this tiny company that is just me, and nobody even knows what my permanent address is. I'm roaming the earth nomadically and asking you to have faith in this. I realise that's a bit of a stretch. Mentioned here, Propensive is a UK-based company, but I have recently, for various reasons, registered in Estonia. Which I hope is a good demonstration of my sort of multiple redundancy. But I have formed a partnership with a company which you should consider much more trustworthy, Vertislab, who you may or may not know, is based in Poland. And they are helping with development and support of Fury. They have over 100 developers. The company's about 160 in size. They're largely they largely take outsourced work from Europe and the US, and they focus in particular on tooling for Scala. They did a lot of work on the Scala IDE, and they're now working on compiler internals. They're working on Dotty. And they organise a conference that's dedicated to tooling in Scala. So for me, they're a perfect match for helping me with Fury. And I get to work with people. I get to give them assignments, and they give me pull requests, and it's great. I'm not used to it. And they're available if you are looking for a company to offer you Scala development work. Vertislab is worth speaking to. And on their to-do list, I've given them various tasks: publishing, which is nearly complete; things like profiling, performance update, performance improvements, integration testing. I'm really bad at testing, so they're going to do that. Exporting to SBT. Why do I want to export to SBT? Well, I want you to feel more comfortable adopting something for which you have an exit strategy if you need it. So I hope you never have to use this feature, but if you decide to adopt Fury, I want you to see a way out if you need it. General bug fixing, support for Windows, which I don't really care about, but some people do. And supporting my various other libraries. I don't know, many of you may use Magnolia directly or indirectly. Contextual, Kaleidoscope, and I've forgotten to close the parenthesis there. Oh no, there's more. Yeah, I've got some other micro libraries as well, all with interesting names. Thesauruses are fun. On my to-do list, I'm going to do some more code cleanup, support for Scala.js, Scala native, maybe Kotlin. Kotlin sort of fits the same model that Scala compiler fits into, so why not? There may be good reasons why not. Integrate support for code coverage, and various other issues. If you think of something that you would like to see Fury do, by all means open an issue. The issue tracker is there on GitHub. And then converting the ecosystem. I've already converted Shapeless, partway through converting Cats to use Fury. It doesn't take long to do a conversion. Shapeless took me about 2 hours. Most of that was trying to understand the original build file. Other projects are actually really very trivial. It can take 5 minutes to convert something that doesn't have many dependencies. Maybe it's just a compiler plugin that you just need to specify the GitHub repository and the sources. So I'm almost out of time, and I am out of time, and I'll just quickly go over the roadmap for Fury. The source code was released last year. I started working with Virtus Lab towards the end of last year, and by January I had a private beta released. I'm probably a couple of weeks away from having a release which I can actually suggest people start using. We're waiting on a few bugs to be fixed in Bloop. A couple of other things I think need a bit of cleanup before I'm ready for that. But a couple of weeks, and I can actually say, try this, and not feel like I'm inviting you to do something that you'll regret afterwards. Version 1.0. I'm not sure when Scala 2.13 is going to be released, but it'll be in the next 2 or 3 months, I think. I would, if possible, like to synchronize a first version with that. And on my flight over here, Vim was working fine, so I wrote a load of documentation for Fury. And you can check that on the Propensive website at that URL. And there's more descriptions on how things work. It's incomplete, but it's worth a look if you're interested, in particular in how the layers work. And that's everything I've got. Thank you.